Math Analyzers, and welcome to your Chapter 5 Lesson 2 notes on adding and subtracting complex numbers, right? So we're looking at imaginary numbers now added with a real number. And the fact that imaginary numbers and real numbers are different number sets is really what we need to remember. We need to recall that they're just not going to really truly combine or add any further. I mean, rational numbers, so your, fractions and your integers, they can't even combine with irrational numbers, different number sets, and they're both real numbers. So imaginary numbers really aren't going to combine with these real parts. So we have this thing called a plus bi form that's we put the real part first and the imaginary part second, and that's how we show that we would add or subtract these real and imaginary pieces if we could actually combine them. Okay, remember that the bi part is it's pronounced bi. I know it looks like the prefix bi, but it's pronounced bi because the b is whatever that integer part is multiplied by the I, right? Because we can multiply those pieces. Okay. Remember that the I is representing the square root of -1. That was our first lesson. That's where the I comes from. And I do repeat that piece right here. Now, here's where you're really going to love this lesson. Since these are unlike terms, all you'll do is combine the like terms. So the things that are i's can add up, their coefficients add up. And the things that are real numbers, those can add up. And that's it. That's how we add and subtract complex numbers. Okay. Now, I'm just going to do a couple of these examples with you. It's your notes are truly just this page, right? Because it's really this simple. Okay. Look for the I pieces. Those are going to add up together. Look for the real number pieces. Those are going to add up together. But your answer has to be A plus BI form. Okay. So your answer is going to have to be A plus BI form. So we're going to do the real numbers first. -9 plus 18 is +9. -14i plus 3i, that's -11i. There's your final answer. The like terms combine, keep the signs with them. Now, this is the part you'll really love. You can just type that into your graphing calculator. So I'm just going to type this in and I'll show you where it is, right? So -14i is the blue button right here above the decimal point, which means if I press second and I, there it is. There's my -14i. So that's it. That's all I type in. -9 and then +3 second and decimal point I, right? Plus 18. And like terms will combine. And look at that. I got the same answer. There it is. This is it. This is the whole lesson. I know. You're expecting something a little more, but this is it for complex numbers. It's nice and easy. I'll do one more by hand and then, of course, graphing calculator. So here we've got this negative that needs to distribute. So really this is a -3 and a -2i. So now let's combine all the i's together and combine all the numbers together. Okay, so I'm going to do the numbers first. -6 plus 8 is +2. +2 minus 3 is -1. So there's my numbers all taken care of. Now I'll do my i's. So 4i plus 3i is 7i. And 7i minus 2i is plus 5i. Now what I'm going to do, just to prove I was right, because, I've always got to be right, is I'll type this into my graphing calculator. 4i minus 6 plus 3i plus 8 minus, and then I'll do the parentheses so the graphing calculator knows that I'm going to distribute this. 3 plus 2i, and then press enter. Ha! Look at that. Same answer. What am I saying by showing you this? You can use the graphing calculator for these. Notice you couldn't do that with the radicals, but with the I, you can. Isn't that nice? Sorry about that. That was a little distracting. Let's do a couple more. Hey, let's see if we can enter C, because see how C See how C has these exponents as part of it, right? Let's see if we can enter this into our graphing calculator. Negative 5i to the fourth plus 3i to the third plus 18i to the second minus 7i minus 14. Let's see if we just enter that and we get an answer. Wait a minute. I didn't even point this part out to you yet. The graphing calculator is giving me my answers in a plus bi form. How fabulous is this? Such an easy lesson. Negative 37 minus 10i. There's your answer. Okay. Let me do this side. 10 minus 11i minus 3 plus 13i, 7 plus 2i. Okay, next. Negative 4i plus 6 plus 3i plus 8 plus, and then in parentheses 3, negative 3, excuse me, plus 2i. That parentheses really doesn't need to be there because it's not a negative in front of it. So 11 plus I. When there's just an I there, what's the coefficient in front of I that I'm just not writing down? 1. And I just don't write it out. We just proved that this works with these small exponents. So I'm going to put those in. Oops, minus 9i squared. Let me get out of that. Plus 3i minus 17. See what we get. Negative 8 plus I. There it is. Guys, you can do this. Use that graphing calculator, that I button down here. It's going to be second and the decimal point on these TIs, TI-83 and TI-84. Works for both. Lovely, refreshing change that we can actually use our graphing calculator. So I think this will go pretty well for you. But if not, let me know. I'm here for you. I'll be seeing you guys soon. Bye.